Okay.
Yeah, we'll start. So this is Dongkyu, and I'm the presenter of Team 3. So as our final project, we introduced an ensemble approach for Wikipedia image caption matching competition. So as the title suggests, we chose a very specific task, and we participated in a Kaggle challenge hosted by Wikipedia. So let's cut to the chase and talk about work. The Wikipedia image text matching challenge asked the participants to match image with the corresponding captions. Here, the test set is comprised of approximately 90,000 images, and the same number of caption and descriptions are given as candidates. So from the image, the model must extract its image features and guess the matching caption as you can see in the slide above. We can make 5 predictions on each image, and the evaluation metric is NDCG with N as 5. Okay, the Wikipedia provides 37 million rows of image and caption pairs, and many of them were damaged and containing, let's say, either just the images or the captions. So using multi-processing, we validated and excluded such damaged data, and at the end, we had 27 million rows of data left, which is still large. And then we chose Clip by OpenAI as our base model, which uses contrasted learning to learn multimodal features. The model will consider the image and corresponding caption as positive pairs, while the other combinations as negative. Clip finds the most matched caption for the image by computing cosine similarity between projected features of images and captions. But the problem was that the original Clip text encoder is trained in English-only context, while our task is meant to match images under multilingual conditions because obviously it's Wikipedia. So we replaced the original encoder with the XLM from Facebook research that aims to achieve cross-lingual understanding. Then we tested the fine-tuning process in 2 stages. First, freezing the text encoder and tuning the other, and then fine-tune both encoders simultaneously. Apart from this, the URL is given in the text submission files. And we thought that URL still remains as a powerful clue. So we cleansed the URLs, calculated the Levenstein distance with all possible descriptions, and then took up top 5 results. So in the end, we'll combine these 2 models. Okay, so here are the experimental results evaluated by the Kaggle estimator. The range of score is 0 to 1, and first with the baseline method using URL, Kaggle estimated the score to be about 0.18, which we used as the baseline score. The vanilla clip model, on the other hand, got 0.17 point, which is even lower than the simple method. So we tried fine-tuning the model while adding multilingual features. But the results haven't shown great progress as anticipated. And so unfortunately, we had to abort the model and rather chose to use an ensemble model. So rather than just using purely learning-based models, we came up with the ensemble method. And here we selected 3 captions from the clip-based model, which we adjusted, while selecting the other 2 using URL addresses. This method uses URL as addition clue, getting 0.33 points at Kaggle. So let's take a look at the actual submission results, and here we brought 4 samples. The image column on the left is the actual image our model must understand, and the column on the right shows 5 candidate captions selected by the model. So let's take a look at the 2 examples. And from the first image, we can see that our the clip model has done well finding the appropriate caption to the images. And this is the image of a watermill in Greek. I think the name is Kikos, and which is what our model expected to be. So the model got it right. But the second candidate caption is also a watermill. So as you can see, the model works well on English. However, our model was wrong with the second image. And if you look carefully, we can see that the model clearly identified this photo as an image of an airport. So the problem was that the main obstacle was that the model couldn't really capture unique proper nouns. The Wikipedia is full of unique names and terminologies, and our general purpose model faced difficulty in embedding or representing such unique nouns. Also, considering the characteristics of contrastive learning, effective training would require large batch sizes, which was something not easy for us due to limited resources. And the results was we marked a point of 0.33 with our ensemble approach and came in 18th place out of 105 teams. And this is all for Team 3, and we are open to any suggestions or questions. And thank you for listening, and I want to give a big applause to everyone who survived the semester. Happy Jonggang.
Okay, thanks for your presentation. Yeah, before we finish, any question? I have a just short question. What does the team name Sharifa means?
It's the address of our teammate, Youwon Jang.
Yes,
What do you mean by address?
No special names.
Yeah.
Just
Okay.
my
Name, I think.
All right. Okay. Thanks for your presentation.